Hello friends, this is Future Dennis. Just to avoid any misunderstanding, I already have a short TCP outline video on my channel where I briefly go through all these things, and if you need to know right now, before I release next videos, if you watch it sooner, how to test the port connectivity, I already have it. This time I'm starting series where I go a bit more in depth, and this is what I usually teach to my mentees. So if you are interested in very basics, you can watch the older video. It has a bit of a worse quality, but it will do. Now you can focus on this training program to learn a bit more, just to understand better. And both videos more or less complement each other. You have a summary and you have series. Thank you, and let's enjoy the video. Hello everybody. Today I'm going to make a long-awaited video about network troubleshooting and practical approach. I'm going to show a few tools that I use in my daily IT life, managing and troubleshooting this, and also I'm going to walk you through the necessary theory to actually understand what is happening. I do plan to start with the very basics, so if you are new to networking, this should still be understandable to you. You know how I usually do stuff. If you watch my other videos, I like to make a component simple and then build more complex structures. So we'll start with basic theory of how the network works, and we'll go up through understanding of each different network layer, and eventually we'll discuss different methods and tools to troubleshoot networking. Now, I must say that it is not critical for you to know all of this. You may not know parts of this, but it really helps to analyze and understand if there is something unusual happening, in order to try to see which component or part of the networking doesn't work. Because theoretically, you could simply rely on ping and trace RT and similar tools and be done with it. But that would never make you a network engineer, and that would never let you catch some firewall or intrusion prevention systems mingling with your traffic. And it would also make it hard to understand how to set up your applications properly to work on the server. So let's start. So if you are coming from a different IT or non-technical background, you may have not a very clear picture of what networking is, so let me quickly display it. So let's say you have a computer. Maybe it's your laptop or it's your desktop PC. Let's say it's a laptop, because many people are using laptops these days. So this is an ugly laptop. And somewhere you have a friend with a laptop. And somewhere there is internet. And on the internet there is a site, some kind of weird hosted solution by a provider of another kind. So what do you do if you want to send a Skype message to your friend? You think like you are sending Skype message and you connect and you see each other on the screen, right? But that's not what's happening. In reality, there is a Skype website somewhere, right? So there's no direct connection in most of the time, especially if you use a hosted service like a Skype. So you must reach Skype website first, and then the Skype website will send message to your friend's computer. Now, how do you use the internet? How do you reach it? Most of the time, you would have some kind of cable or Wi-Fi that goes into the router. And the router may be in your apartment, it may be somewhere in the basement of your house, or maybe on the street. But this is a network device, which is like D-Link or something else, which has a network card. It has a special antenna to broadcast Wi-Fi signals, and it has ports to plug in your cables. So this router goes somewhere, and actually this is a chain of switches and routers which are handled by another company. They are not yours. This is ISP, Internet Service Provider, like Telecom, DG, Orange. So it could be any kind of company which provides equipment to connect computers together. And eventually, through the series of internet switches and routers, this reaches another location where Microsoft hosts the Skype. So theoretically, you must send your network information through your cable, through the router, through a bunch of switches, and then it should go to the website, and then it should also go all the way back to your friend's computer through a series of switches to the router that he has, and then to his computer. So it is a very complicated setup if you look at it this way. It may look impossible to understand what's going on. However, in reality, there is only a few standards that are used here, only a few messaging types and a few protocols that are in play, and there is a limited number of tools that send data, receive data, and can read data. So if you master the basics of networking, you can more or less unveil and understand any kind of complex setup. Of course, at first, we are not going to focus on such complex situations. We are going to talk about what's happening when you have two computers connected to the same router. And it could be even a switch. It's not a router because it doesn't go to the internet. It only connects multiple computers together. So if you have two computers connected to a device, this device could be a router or switch. The difference is typically that switch is designed to work with local network, and the router exists between multiple networks. But right now, we are only curious that there is some kind of box where you plug in your computer devices. So in order to understand how all of this works, you would like to rely on a specific model. There are two commonly accepted models, and usually if you go for an interview, you'll be asked if you know them. There is OSI model, and there's TCP IP model. Very shortly, I'm going to draw you these models and explain them in a practical way. So it's going to be easy to connect what is this model and what do you actually see in your apartment and what's happening. But right now, what we need to understand is that these computers need to somehow communicate. So there must be some kind of cable between them. I'm not going to make a special information about Wi-Fi, because while it's commonly used, it's a special kind of technology. If you want, I can make another video about Wi-Fi. We are going to talk about basic cables, because if you know how electricity works, you can understand what's happening here, right? So these two computers need to talk to each other. It means that one computer needs to send data and another computer needs to receive data. It means that the device in between should understand what is a source of the request and what is a target of the request. So this is the concept which is used in all network communication. There is outgoing traffic and there is incoming traffic. And the traffic itself, because it's not some kind of a magical, flying message, it's just electrical signal. It needs to carry the message, where it's coming from and where does it come to. So keeping this in mind is very important, because every time you have a problem, you need to understand if you fail to deliver, if it reached the target, or if it failed to reach the target and kind of got bounced back before. Like with emails or any other messages. Like, for example, if your package that you send through DHL is lost in transit, you will want to know in which country and in which distribution center it stopped. And this is where the network information troubleshooting will help you to understand which device or which kind of link breaks or doesn't work or doesn't allow you to go through. So the most typical problems for troubleshooting are: 1, misconfiguration. Because if you do not set up the network correctly, or if network administrator you rely on doesn't do that, it will not work properly. 2, could be just physical world, right? Physical errors, which means it could be a bad cable. Maybe your cat chewed on it. It could be a janitor cleaning the apartment or an office block and tripping on the cable, or it could be logical. And logical errors kind of come together with misconfiguration. I can explain this that way. But let's say if it works most of the time but doesn't work sometimes, there could be either not enough throughput, which means that some of the devices stops functioning properly. It could be a firewall blocking it. It could be an antivirus, or it could be some external scripting tool or virus actually, or malfunctioning program dealing with this. So we are going to first understand how the network should work, and then how can we find out what is the error. Because typically if there doesn't work in some application, you should be able to reproduce this error or capture it with another software which provides you with better understanding. In this case, we are talking about network tracing tools. You can rely on Wireshark, you can rely on TCP dump and other types of software, which we'll discuss in the very end. Because right now for us, it's important to understand first, how does the data go from point A to point B? So we have these two models, OSI and TCP/IP. TCP/IP are actually two names of specific protocols, because I am sure most of you have heard about IP address. So each computer has IP address, and there is this saying like, I'm going to find your IP, and like, I'm going to know where you live. Well, in modern world, it's completely useless most of the time, because the IP you have in the internet is the public IP that is given to you by your internet provider, and it may belong to a few structures or a few blocks, because there is specific technology called NIT, network address translation, and that's where your IP changes. But right now, because we're talking about two computers connected to the simple network, we are going to actually agree that IP will belong to the computer who is sending, and another IP will belong to the computer who is receiving, I mean IP address. And TCP is something of a different beast. This is how applications talk. So IP is how you connect. So if you don't have IP connection, you don't have connection at all, let's say. And after you have IP connection, you can have connection for one application, but block the other. For example, this is how firewalls work. You can allow Skype to work, but block a browser. Or you can allow remote desktop to work, but block access to Facebook and specific applications related to that. So both of these protocols come hand in hand right now, especially with the way Windows and Linux and other systems use applications. OS style is more of a theoretical model. So basically what happened, OSI was invented quite a while ago. It was built out of the necessity. So people decided how to make a network. And then the protocols were developed to fit OSI model. In case of TCP/IP, people build the configuration and the protocols using OSI, and then based on the result, the TCP model was built. So you can think of TCP/IP model as being more practical. But we can still rely on both because they carry useful knowledge. So why do we have this model? What does it mean? It means that the data is not simply an electrical signal. It carries useful data. So there are multiple layers of abstraction. So technically, if you look at this picture, the following thing appears. At first, there is a very first layer for OSI. And this is called physical layer. And this physical layer is basically where all your main signals go through. Then you have data link layer. And don't worry if the names do not make sense, because I'm going to explain them in a more, let's say, real world example. Then there is network layer. And then there is transport layer. So far it may not make much sense, but very shortly we'll start talking about this and you'll see what's happening. Let me make it a bit nicer looking. So physical, data link, network, and transport. Okay, hold on. I'm better drawing, but I'll improve as I make these videos. Network and transport. Okay, and above there are a bunch of layers which are called session, presentation, and application. So right now, we are not going to talk much about the the bottom three. So we have layer 1, 2, 3, 4, which are the most interesting for us in terms of most of troubleshooting, and then 5, 6, 7, which are a bit less interesting, but in total there are 7. So what do we mean by physical layer? In reality, there are cables. If it's Wi-Fi, it's going to be some kind of Wi-Fi signal. It's still a signal going through the media, like air. But if it's a more simplistic approach, then we have 2 cables. So here we have 2 cables, let's say. There's actually more. If you open up this cable for the internet connection, you'll see there can be 4 or 8 cables. And they're also twisted. I have a picture for you to show it shortly. It looks like this, right? So This is also called sometimes twisted pair, because you have twisted cables, and because they're twisted on physical layer, they're actually improving conductivity. But you don't need to talk about physics now. We don't need to think about it. So we have multiple cables. So how do we carry signal that is useful for the computer through these cables? Well, what's happening is that one cable has, let's say, we are talking about one pair. We have cable 1 and cable 2. One cable goes with signal. It goes higher, it goes lower. It goes higher, it goes lower. Another cable is what we call a clock. It is a bunch of signals which happen with the same frequency. So whenever clock hits, that's when we check the signal. Is it high or is it low? So if it's low, it becomes 0. If it's high, it's 1. 0, 1, 1, 0, 1, 0, 0. And this way, on the physical level, you get the sequence of numbers. And this is the binary data, as I explained in the data storage video, which represents your real data in the computer. So because of these ones and zeros, in the end, you receive useful data. This is how data is written on CD-ROM, on hard disk, etc. So the network has this bunch of ones and zeros. And that's it mostly. Now, the question is, how does this data get, let's say, connected to specific endpoints? And how do we see in network which devices are which devices? Well, now we are talking about data link layer. So we need to have some kind of linkage between them. So we could have a source and a target of the connection. So if we are talking about a linkage, the devices must be somehow identified. So you have computer 1 and you have computer 2. And they're not actually connected to each other through some strange way. There is a very specific standard. You always see the same hole for the network cable. The cable type is called RJ45. And I'll show you shortly what it looks like if you haven't seen, but I'm sure if you have ever worked in the office or if you have a specific type of connection at home, you will see it. Open image. Okay. So it's these kinds of connections. And RJ means registered jack because it's actually some kind of standard. Jack is how we call the end of it, and registered is because it's registered. And 45 is a standard typically used for the network connection. So in the computer, you must have a hole. Some computers do not have it. So what gives? There is a specific device called Network Interface Card, or NIC. So if you read the book or documentation and you see NIC, it's a Network Interface Card. Network Interface. Or to say it in simple words, it is a network card. So the cable goes between network cards. So we need to understand which network card belongs to which computer and how are they different. Because otherwise, if they were on the same cable, they would look the same. Well, network card, network interface, they have a specific identifier, which comes from when they have been repurposed or manufactured, and it's called MAC address. So this MAC address looks quite interesting. It looks like a bunch of letters and numbers. I'm going to show you what it looks like, but don't pay attention to what I do first. I'm just going to the command line on the computer and I'm typing ipconfig. Right? Hold on. It should be ipconfig/all, so it gives me all information. So this is typically how you receive information about your network card. So Ethernet adapter is my network interface card. And this is the physical address, which looks like doubles of letters and numbers in hexadecimal system with dashes in between. So another computer on the network will not have this number. And this is how the switches and other network devices know that there are different computers and each of them has a specific manufacturer ID, basically, or physical ID. So MAC kind of connectivity happens on data link layer. So this is where you have the MAC address. So physical is your cable, and data link is where you apply the knowledge of MAC addresses. It also kind of bleeds over into network, because theoretically you could make network without IP addresses, only using MAC addresses. But let's not dig deep into very specific scenarios. So what happens on the network layer? On the network layer is where the computer works with IP address, because MAC address is nice when you have one network. Your single network is going to be relying on these physical addresses to understand what is what. But if you want to go to a different network, you will want to create a set of rules. Like you can go from one network to another and to another. Like in my example, where I have given the connectivity to Skype server, you have to go through a lot of devices, and each of them is on a different network. So if the computers are connected together by a single switch, it's called local area network, LAN. So here we have LAN at home, and your friend has LAN at home, but they are not the same LAN, and they cannot be used to communicate to each other. So there should be some kind of a router device, and the router devices work with IP addresses. So IP address is another type of address which can be used to send traffic, receive traffic, and also we have implementation which allows us to connect multiple networks. Now, one thing you cannot do with IP addresses, you cannot have two LAN networks, LAN 1 and LAN 2, which have the same IP addresses, like 192.168.0 and then some number like 5, and here 192.168.0.6. This is how IP addresses look. If you go to IP config, you'll see my IP addresses here. And I'm not afraid to give it to you. You cannot find me by my IP address because you are likely to get the same IP address at your home. So if there are two networks like this, you cannot connect them together through the router if they are in different areas, because in this case you would use a switch, and because the networks look the same, it means that the specific part like this one of the network, which is in front, is the same, then it would still be the same LAN. I hope it makes sense. I can explain why, because when you go to another IP address, if it looks like it's from your network, you will not go to the router. You will not go to the routing part of the router. You'll try to find this IP inside of your network. And if you do not have, like, if you try to ping 6 and you go to address 6, because this one is 5, if it was in another network, you wouldn't route into a different network. You would try to find it in your network and fail to find it and say there is no such IP. So you can connect network which look different. For example, 172.168. So in this case, you can have a router, and the router will know if you go to 172 address here, it will go to the router and end up on a different location. So the point of IP is not only to identify the computer, but also to have a specific function of identifying the network. So the MAC addresses, they do not make a network. They are unique for each computer. The IP addresses carry information about the LAN, which network you are in. And this is why, because you understand which network you're in, you can route to a different network. Okay, so the IP address exists on network layer. And there are actually two types of IP addresses, IPv4 and v6. I can show you again. I don't have it disabled. So I have IPv4 here, 192.168.106. And I also should have IPv6 somewhere if it's not disabled. Let me see. Here, local IPv6 address. And it looks like a bunch of letters and numbers with delimiters. And the variety of IPv6 can be much, much higher because we can use letters, numbers, and symbols. IPv4 has only so many combinations you can have. So typically, IPv6 is way more flexible in terms of how many computers you can have. Practically, most of the internet still uses IPv4 because you would have to modify and enable IPv6 in all the devices around, configure all name servers, etc. IPv6 will be required at the point where we will not have enough IPv4 addresses. So far, we are still working on that. Like we can work with the existing range. I can make a different video explaining what IPv4 address is, but you can look it up pretty easily. Basically, the most important thing for you to know is that it doesn't go by itself. It also has a network mask. And the network mask, subnet mask, which exists along with the IP, tells the computer where is the network. So very shortly, if the mask is 255.255.255 and then 0, it is a very frequently used mask. It means that the first 3 addresses are used by network, and where you have 0, this is where is the computer or host address. So now I can have up to 254 computers. Well, I think 3 because one of the addresses is in use, but basically it goes from 1, 2, 3, 4, 5, etc. up to 254, right? And 255 is like service IP address, and 0 is address of the network. It may be a bit confusing, but just imagine that if you see the network address, like any address, and then the mask is 255.255.255.0, then the first 3 numbers is your network. So if you ping any IP addresses with the first 3 numbers like this, you will not go through the router. It will only look at the last number that you have. And there is one more important thing to know about IP address, is that there is a gateway IP address, and this is IP which is used to get to the router. So when your computer pings something that doesn't look like your network address, this connection should go through the gateway. You can have multiple gateways for multiple rules. You can set up routes, etc., but that's a bit of an advanced setting. Normally, we don't use that. And I can make an extra if somebody is asking me how to do it. Right now, it's not critical. Okay, so let's go. We have IP address assigned on this layer. So now the good question is, how does the MAC address and IP address correlate? Well, between these 2 addresses, there are 2 types of translation. There is ARP protocol for IPv4, and what's the name for the second one? Something public discovery or neighbor discovery. So here we have ND protocol. So basically there is a specific protocol, and if you are talking about the way it's implemented on the router, there's like a table which says this MAC belongs to this IP. This IP belongs to, well, has this MAC. So it's like a specific ARP table which tells the router which computer has which IP address. And there is a service called DHCP, which I explained shortly in my stream about Active Directory, which was a bit of a nightmare, to be honest, to make. Then basically, without MAC, you cannot have proper IP. That's how you see it. So, okay, we have 2 computers now. I'm going to draw it here, and I'm going to erase it later. And here is a connection. We have source IP, and we have target IP. And it looks like it's clear what's going on. Internet protocol connection works. But there is another problem. Let's say you're connecting with a browser. Or even easier. Let's say you're connecting with a remote desktop protocol to another computer to see what's on the screen. And that uses this connection. But you may also send a message, like through some kind of internal messenger. So in this case, you have 2 connections going through the same IP address. And because it's just a binary data, there is no differentiation between which connection is your remote desktop connection and which is your messaging connection. So in order for different applications to differentiate traffic, so to understand basically if this is an information which is sent to remote desktop or to the messenger, there is another concept of protocol ports. So it could be TCP ports, it could be UDP ports based on the type of protocol. So let's say there is TCP port, and for example, for the messenger, it's port 25. And for RDP, it's 3369. So when the information is sent, one of the connections will go to port 3369, and another connection will go to port 25. So while technically it still uses the same IP address, there are 2 connections because there are 2 different target ports. And it's also important for the future to know that when the connection is happening, there is an outgoing port. So the TCP will assign, let's say, I don't know, 50,342 as an source port. This is important because when the software replies back, especially in scenarios with routers and switches, it may be important to understand which port it came from to send back to the same port. And because it doesn't really matter which port you send from, most of the time, usually, outgoing ports are random. They are called dynamic ports. And target ports are static, and they belong to different applications. I will show you how to see which ports are in use. There's command net stat for that, but I'll show it. And this is how you can see why the connection of some kind is working and another kind doesn't work. As the final destination of today's lesson, I'm going to show you how to troubleshoot RDP connection which doesn't work. In our case, it will be firewall blocking specific port, and we'll go through all the necessary commands and tools to get. Typically, when you troubleshoot, you go from bottom to top. So at first, you verify that there is a physical connection, then you verify that the network is set up properly like a local network, and then you start looking at the IP address assignment, and eventually go to transport, where you have TCP or UDP. Or there could be other protocols theoretically, but these are the two main protocols that we use right now. So you go with different tools and commands which test everything from the bottom. Obviously, you don't have many commands to test physical connection. It will look like it breaks on data link or network level. But knowing that there is no connection and the settings are correct, you can send somebody to the data center to fix the cables. Okay, so that has been a while since I cleaned it up. Give me a second, I'll do that. Okay, this looks better. So now we are going to quickly recap what I told you, and then we are going to look at the same on the TCP model, just to make the comparison. So at first we have, on physical level, we have cables, which send electrical signals, which actually translate into ones and zeros. Now, and then it goes through local area configuration, where you use MAC addresses for connection, and then eventually use IP addresses to connect multiple computers in different networks together. And then you use TCP or UDP and ports to actually connect different applications. And then when it goes to specific application, one application can have multiple connections, and this is where you have sessions and other types on top. But these are less important unless you troubleshoot a specific application and if you want to see what's happening on that level. So quick explanation. How do we get to actual data? So here we have binary, and doesn't mean much, right? So how do we know what's happening? Actually, a specific sequence of ones and zeros becomes a frame delimiter. What does it mean? It means that whenever a network application receives a specific number of ones and zeros, it says, okay, this is the beginning of frame. So here we get Ethernet frames. What it means is actually it's a sequence of data which is useful. So you get something that says, okay, now we start the frame. Then you use basically the rest of the frame for data, and then the frame ends because we know the length of the frame from the beginning. So we know where it will end. And then another frame starts, etc. So, and all of these frames use basically binary data inside of them to create another type of data carrier called packet. So on IP level, we have IP packets. The packet also has beginning and an end, like Ethernet, but basically you can have multiple frames which end up in a packet. A quick intermission. I noticed this as I was editing. Actually, you don't always get frames in a packet. If your network is designed specifically for IP, your IP packets could be the same as frames, and vice versa. You could have a different situation. It all depends on specific setting, which you don't usually normally touch as support engineer or troubleshooters, but you need to be aware of it. It's called MTU, maximum transmission unit. So if this setting is not properly set up for the network where you work, you can have a lot of, it's called packet fragmentation. So basically, your packets will not be coming in a single piece, they'll be very fragmented. So in general, if you are responsible for the network, you would want to set the setting accordingly. And it also has start and end. So the way it's done, every packet has a header. In the beginning, header is like, I don't know, a summary of a book, which tells you all the parameters you need to know about it, what type of information it carries. And then inside you have the actual payload. And this is where you have your useful data. And there is another technology called encapsulation, because inside of the IP packet, you'll have multiple TCP packets in the payload, because multiple different applications can talk at the same time. Like your Skype doesn't wait for your YouTube video to finish loading. It goes together. So here you have TCP or transport layer protocol packets, and each of them has the same idea. It has a header and data, header, data, header, data, right? So in the end, you receive a bunch of really useful data that has your network information, but it is packed, or rather separated, in small pieces called TCP packets, which are delivered by IP packets, which arrive as Ethernet frames, which are actually a bunch of ones and zeros, but because we know how they start, we get where they start and end, because we have these delimiters between frames. Now, you may have a good question: what happens if a part of information is corrupted or missing, or maybe lost because connection doesn't work 100% of the time? Well, if there is a problem, let's say here something didn't go through the payload, you will miss one of the TCP packets. And this is where you understand the difference between TCP and UDP. So if you use TCP protocol, because of the verification that is inbuilt in the protocol, you'll be sending the packet and you'll be expecting an answer. So if you do not get an answer, you're going to send the same packet again. So even if you lost the packet here, you got a packet loss. Your application will still receive this packet just a few moments later. And this is what may cause network delays. So your speed of the network is not always necessarily the fastest, because your devices are great and they have this very fast ones and zeros. I forgot to mention it, but because of this clock, the faster it goes, the faster is your connection, basically. And this is why you have different connections. Like you have 1 gigabit connection or 100 megabit. It's how fast your ones and zeros flow. But your network speed can also be affected by the fact that you're sending a lot of data together, and sometimes you retransmit data. Now, when we are talking about UDP, what it does, it just keeps sending packets, and it doesn't ever receive anything back. This is why when you watch streams on Twitch or YouTube streams, those software types use UDP because it gives a lot more information at once, but you may be dropping frames because the frames don't go through, and the application in the end will not receive your full data. You'll notice there is a choppiness, some kind of artifacts, but overall the message goes through faster. This is why it's used in streaming technologies. All right, so this hopefully recaps what we discussed regarding different layers. And I'll briefly show you what's the difference with TCP IP model in comparison to OSI model. Okay, now that I have done away with useless information that we no longer need, let's look at TCP IP model. So in TCP IP model, we only have 4 layers. We have one layer below, which is called network interface. And you may see the correlation with network interface card. So it's our Ethernet card. Then we have another layer, which is sometimes called internet and sometimes just simply network. Then we have a layer which is a bit higher, which is called transport layer, which is similar to what you see on the left. And then you have another layer, which is called application layer. I can explain to you very easily why this model looks much simpler. So there are only 4 layers. Technically, if the MAC addresses do not work properly for the network cards, or the cables are bad for a person who is doing remote work and troubleshooting connection, it's the same kind of a problem. And unless it's fixed by local engineers on site, the network will not work. So they need to use proper cards and proper cables. So all of this has been stuffed in the network interface. Now, when it comes to IPs and IP communication and network address translation, etc., this is where we are important as network engineers who work remotely. So this layer is still the same. Same about transport layer protocol. We need to be sure that TCP packets are going through, that the firewall doesn't block them, that there are not too many retransmits, and if they break somewhere, we need to catch the location of the problem. And then when it comes to application, this is again, so the bottom layer here is kind of meh, and the top layer is meh, because on the application layer, usually we talk to support company or to support department of specific application. So mostly we are interested in specifically transport and network layer, but we need to be able to catch network interface problems, and we need to be able to actually explain transport and network layers to troubleshoot application layer. This is why working in support for my backup application company, I need to know all of this so I could properly troubleshoot it on the application layer. Because if I don't catch the error below, it may look like a software problem. But if it isn't, I'm going to be wasting my time on only looking at the application logs instead of using proper network tools. Okay, so hopefully now the model itself makes more sense, and you can have the comparison between the electrical cable in the line and your packets coming through the actual data. So this video is just the beginning of the series of different concepts that I would like to explain. And I have quite a few tools I work with frequently, so I can show you how to work with Wireshark, the port testing tools with specific scenarios. If you do like this way of explanation, please like the video and leave a message. I'm not doing this for monetization. I'm just enjoying the fact that if something happens to me, you guys will have at least some kind of useful information coming out of my mouth as a result of my years of working in IT. And if something I say doesn't make sense, if you want to bring some extra information to the discussion, I will really enjoy talking to you in the comments. So the next video is also probably going to be a bit basic for those who are advanced network engineers, because I'm going to just explain the basics of IP and MAC configuration, DHCP and ping and traceroute. But we are going to get to the more interesting stuff eventually, because without these explanations, it's really impossible to explain what does Wireshark do to the person who hasn't been working in this field or who wasn't focused on this. Thank you so much. Again, if you do like it, please leave a like. If you don't, leave a dislike. I'll be sure to remember that and try to improve myself. And if you have any constructive criticism, if you would like to leave a comment of what can be improved or added, I will welcome that, and I'll be happy to see you in the next video. Bye-bye.